Do you know how to keep multiple networks completely isolated on the same physical hardware? If you're thinking VLANs, I'm sorry, but you're wrong. Today, we're talking layer 3 and breaking down what a VRF is. VRFs, or VRFs, stand for Virtual Routing and Forwarding, and it's basically a way to virtualize your router. Normally, a router has a single global routing table that handles all incoming and outgoing traffic, but with VRFs, you can create multiple isolated routing tables on the same physical router. It's like having multiple routers in one box without all the extra hardware. Why is that useful? Well, it's perfect for scenarios like network segmentation, multi-tenancy environments, and especially dealing with overlapping IP addresses. Let's say you're taking over an existing network, maybe through a merger or an acquisition, and that network already has its own IP scheme. But there's a problem. Their IP addresses overlap with your existing network. Without VRFs, this would be a nightmare. You'd have to readdress everything, causing downtime and a ton of work. But with VRFs, you can keep the overlapping IPs isolated in their own virtual routing table. For example, if both networks use 192.168.1.0/24, you can set up a VRF for the new network. Devices on that VRF will only communicate through their designated routes, avoiding any conflicts with your existing infrastructure. It's like having two completely separate networks running side by side on the same router. No readdressing, no headaches, just clean, logical separation. Setting up a VRF is actually pretty straightforward. You create the VRF instance on your router, assign interfaces to that VRF, and then configure routing within that VRF separately from your global routing table. And if that doesn't make sense, it's okay. Here's a quick example. This small configuration right here creates a VRF instance called new network and establishes a separate routing table, isolated from the global routing table. Next, it assigns the interface gigeth01 to the new network VRF, and the IP address is set on this interface within the VRF. Now, any traffic entering or leaving this interface will use the new network routing table, not the global routing table. This allows you to use 192.168.1.0/24 in this VRF, even if the global routing table or another VRF is also using that address space. Devices connected to gigeth01 will only interact with networks and routes defined within the new network VRF, maintaining complete isolation. VRFs are a great way to maximize your network hardware, whether you need network segmentation, multi-tenancy, or want to avoid IP conflicts. VRFs let you do it without piling up the hardware. Instead, you get the flexibility of virtualizing your routing tables, giving you more control and efficiency. I'm obviously a fan of VRFs, but what do you think? Are they a lifesaver for complex networks, or do they just add unnecessary headaches? Let's hash it out in the comments, and don't forget to follow me, you nerds.